Hi everyone, it's Mrs. Summer here to talk about the Unit 2 review. So the first part of the review is from Lesson 201, Types of Chemical Bonds. So the practice problem says fill in the chart. So it's asking how is the bond formed? So ionic bonds, the bonds are formed by transfer of electrons. In covalent bonds, the bonds are formed by sharing electrons. And in metallic bonds, they are a sea of electrons. So the electrons are able to move freely about the structure, and they aren't they aren't required to be tied down to one specific proton or one specific nucleus. So the physical properties of ionic bonds is that they are always solid at room temperature. They have very high melting points and boiling points. They are hard and brittle. They conduct electricity only when melted or dissolved in water. And they're very soluble. They dissolve, which means that they dissolve in water. Okay? So covalent bonds, their physical properties can be solid, liquid, or gas at room temperature. They have low melting and boiling points. They cannot conduct electricity, which is really good if you think about gasoline, which is a covalent bond, covalent molecule. And I'm very thankful that gasoline cannot also conduct electricity. They are insoluble in water. Think about when you have oil and water, they do not mix. And compounds are often called molecules. With metallic bonds, the physical properties are in incredible strength. They're malleable, which means that they are bendable. Ductility, which means can be stretched really thin. Think about the copper wiring in your house. And they conduct electricity in all states. So that it can be solid, liquid, or gas, and those conduct electricity. And then luster, they're shiny metal objects. Lesson 202 was Ionic Compounds formula to name. So here it wants us to write we have those backwards, but we're going to write the name given formula in this part. So CuO. So how we do that is Cu is our cation. But copper is a transition metal. We don't know its charge, so we're going to put a little X. And then we have oxygen. Oxygen has a fixed charge, so its charge is always 2-. So the CuO in the final formula, because it's an ionic compound, it should have a 1 here and a 1 there, but we don't write it because it's implied. So it's in the lowest ratio possible. So here we know that we didn't have to crisscross anything because the charge is added up to 0. So we know that this X plus negative 2X, so X plus negative 2X has to equal 0. So what is that value? 2. So here we have copper, and then here's where we use our Roman numerals because copper can have more than one charge. So in its name, we have to identify the charge. So here, copper 2. And then we have oxygen, which is, we change the ending to oxide. Okay, oxygen's a little confusing when you change its name. It's not oxygenide, it's oxide. And then another example we have is Mg3P2. Well, our cation is Mg, which is magnesium, and magnesium is a fixed charge. So we just write its name, magnesium. Simple enough. And then our anion is phosphorus. Well, we change the ending of the phosphorus, so change to IDE ending. So magnesium phosphide is the name of this compound. The next part was ionic compounds. Given the name, write the formula. Well, this is a little bit easier to do. So in this question, iron 3, so iron symbol is Fe, and its charge is 3 plus. I know it's 3 plus because this Roman numeral tells me the charge of the cation. And oxygen, so oxygen is always a -2 charge. So here's where the charges don't add up. It doesn't add up to 0, so we have to crisscross our charges. So we're going to crisscross here, and we're going to write our formula as Fe2O3. So the formula for iron 3 oxide is Fe2O3. Another example is lithium nitride. So because there's no Roman numeral in there, we can assume that with this ionic compound, lithium has a fixed charge, and it does. Lithium is Li, and it always has a +1 charge. Nitrogen, or nitride, is N, and it always has a -3 charge. So those charges don't add up to 0. 1 plus -3 does not equal 0. So we need to crisscross again. And when we do that, we get Li3, and N1, but we don't write the 1 in our final formula. So I get Li3N as my final answer. So in lesson 204, we drew the Lewis dot structures for ionic compounds. So here's one directly from one of your mastery checks, magnesium iodide. And this is one that, at least in my class, many kids were incorrect because they were drawing the covalent structure for an ionic compound. So we first start with our magnesium. Magnesium has 2 valence electrons. Iodine has 1, 2, 3, 4, 5, 6, 7 valence electrons. So this valence electron is going to go right there. We can, where's my eraser? There's my eraser. We can do this. So this valence electron actually is right here. Well, now iodine has 8 electrons around it. It's happy, but magnesium doesn't. Magnesium still has that 1 lone electron, which means we need to bring in another iodine. Okay, and then so this electron is going to go wee all the way over there. And then we're going to erase. We can erase this. And that. And so this valence electron is here. Now magnesium's happy because it got rid of its valence electrons in its outer shell. And iodine is happy because it's got a complete octet in its valence shell. So the way we write these Lewis structures is that magnesium, we use the brackets and we left 2 plus. And iodine, we have I, and then 1, 2, 3, 4, 5, 6, 7, 8. And then it's -1. And then we do it again. I, 1, 2, 3, 4, 5, 6, 7, 8, -1. Okay, because ionic compounds, they transfer electrons. They don't share them, which is why their Lewis structures look different than the covalent bonds. So this other example, cobalt-3 nitride. So we're going to use cobalt, and this 3 is telling me that it's a +3 charge. So I have 1, 2, 3 on cobalt. Okay, nitride has 1, 2, 3, 4, 5 valence electrons. So this valence electron from cobalt go all the way there. And then we can erase right there. But now cobalt still has 2 valence electrons. So this one's going to travel all the way around here. We can erase it. And then we have one more spot on nitrogen, can accept one more. And now cobalt is happy because it got rid of all of its valence electrons. So we're going to write it as cobalt. And I'm going to write my O smaller because cobalt is C, capital C, little o. Then we're going to write 3 plus. And then for nitrogen, I'm going to do N, 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to put a minus 3 charge. Okay. Our next lesson was 205, polyatomic ions, names to formula. So the thing you need to remember about a polyatomic ion is it sticks together. It stays together. You don't break up the polyatomic. Just like girls going to the bathroom together, they stay together in one group and they all go together, pre-COVID times. And they don't get separated. Okay? So the carbonate in here is our polyatomic. So our first one is strontium, and we write Sr, and it has a 2 plus charge. Carbonate is CO3, and it has a 2 minus charge. Now, this whole thing has a 2 minus charge. Okay, so then we're going to crisscross, and because our charges add up to 0, we can still write it as in the lowest ratio of terms. So our formula is just SrCO3. The next example is iron 2 phosphate. So just like in the previous lessons, iron 2, that tells us our charge, so Fe2 plus, and then phosphate. Phosphate is PO4, and it has a 3 minus charge. So I write PO4, 3 minus. Well, now my charges don't add up to 0. I need to crisscross and write my charges down there. And so I'm left with Fe3, PO4, 2. And you need to put those parentheses around the PO4 because there's 2 different groups of the phosphates. And remember, they're like girls going to the bathroom, they stay together. So you need to represent them staying together by putting parentheses around them. Lesson 206 had us doing polyatomic ions. Given the formula, write the name. Now in this first example, my cation is copper. Copper has a variable charge, so we don't actually know what its charge is, and so we have to figure it out. My OH is my hydroxide ion, and that always has a charge of -1. So if we look at our formula, so I crisscross this, and I'm left with Cu, and then that 1, so we don't write it, but I'm going to write it there, and then OH, and then X. Well, if we compare our formula, X is 2. Okay, so I know it's copper 2. So copper 2, I'm going to write copper 2, and then that hydroxide ion, copper 2, hydroxide. Okay, the next example, CaClO3. So calcium is a fixed charge, so we just write calcium. No worrying about the charges or crisscrossing and working backwards. Calcium has a fixed charge, so we just write its name. Then the ClO3 is chlorate. So the chlorate, so calcium chlorate. And that's the name of CaClO3, 2, calcium chlorate. Now, with lesson 207, we moved on to naming compounds, covalent compounds. So covalent compounds, we use those prefixes, mono, di, tri, tetra, etc., in order to name our compounds. So dicarbon monoxide. So dicarbon, di means two, so C2. And then monoxide is one oxygen. Okay, mono meaning one, so there's only one oxygen atom. This next example, we have hexanitride, pentafluoride. So hexa is 6, so N6, pentagram, five sides, pentafluoride, so F5. It's a little bit easier to write the formulas and naming covalent compounds than sometimes it is with ionic. But here's where it gets a little tricky with lesson 208, Lewis dot structures for covalent compounds. Okay, so nitrogen trichloride. So we're just going to start by writing NCl3. Okay, so nitrogen has 5 valence electrons. And there's only one nitrogen atom in NCl3 for a total of 5 electrons. Chlorine has 7 valence electrons, but there are 3 chlorine ions. So we have 26. We have 21 electrons there. And then we add 5 plus 21, we have 26 electrons that we need to account for in our structure. So I'm going to start by placing nitrogen. Then I'm going to place chlorine, and chlorine around it. Nitrogen has 5 valence electrons. Chlorine has 7. So we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So now, if you can see where the purple and red are together next to each other, that's a bond. So we can rewrite our structure as N, and then a line between where the bonded electrons are. And then we have 1, 2, 3, 4. 6, and then nitrogen still has 2 extra electrons. And then we 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So yes, we've correctly accounted for all 26 electrons in our Lewis dot structure of nitrogen trichloride. So oxide is a little bit different because it's just 2. Remember, oxygen is a diatomic. Oxygen is O2. So here we've got each oxygen has 6 valence electrons, and there are 2 of them, so we have 12 electrons to account for. Okay, so we have oxygen and oxygen, kind of only way to put 2 molecules together. And then each one has 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 valence electrons. Well, we're going to start off by sharing a pair of valence electrons. So we're going to get one from here and here. Okay? So we've got now each oxygen. So how many electrons do we have surrounding it? 2, 4, 6, 8, 10. We have 12. But in this case, oxygen likes to bond with itself. So we're going to have oxygen, and then 1, 2, 3, 4, because it needs to have 8 valence electrons around itself. And here, this oxygen has 1, 2, 3, 4, 5, 6, 7. It only had 7 valence electrons, so it wasn't happy. It wanted 8. And then 1, 2, 3, 4. So in our new structure where we put a double bond in, we had 2, 4, 6, 8, 10, 12. We've accounted for all of the electrons. But also each oxygen has 2, 4, 6, 8, 2, 4, 6, 8. Each electron has 8 valence electrons around it. So it's met the octet rule, and we've accounted for all of the electrons. Lesson 209 was mixed practice. So in this question, here's the formula. Give the name. Well, it's K3N. Potassium is a metal. Nitrogen is a nonmetal, so it's an ionic compound. So this is ionic. So we use our ionic naming. So this would be potassium nitride. Okay, now sodium iodide. Sodium's a metal. Iodine is a nonmetal, so this is ionic. So sodium is Na, and it's got a +1 charge. Iodine is a -1 charge, so our formula is NaI. SF6. Sulfur is a nonmetal. Fluorine is a nonmetal, so this is covalent. Okay, so I have 1 sulfur, so I'm just going to write sulfur. And then I have 6 fluorines, so I have hexa fluoride. Be careful with the spelling of fluorine. It's kind of different than what we normally see. It's FLUO, not FLOU. Okay, this next one is FeClO3 2. Now, iron is a transition metal, and then this is a polyatomic. So we're going to still say our ionic compound. This is chlorate, and so the chlorate ion always has a -1 charge. So we have our Fe, and we don't know its charge, but ClO3 always has a -1 charge. So when we crisscross it, this X here, the charge on iron, is going to be the subscript on the chlorate ion. So it's iron 2 chlorate. The next example is magnesium nitrate. So magnesium is Mg2+, and nitrate is NO3 -1. So our formula would be, when we crisscross them, we get MgNO3 2. Our next example is CO2. Carbon's a nonmetal, oxygen's a nonmetal, so this is covalent. So we use our covalent naming conventions. So we write carbon, and then O2, dioxide. Our next example would be diphosphorus pentaoxide. So diphosphorus, so phosphorus is P, and there's 2 of them. Pentoxide means oxygen, and there's 5. This next example is CuHCO3 2. So the polyatomic here is bicarbonate, so it's going to be bicarbonate. But we need to know what the charge on copper is. Bicarbonate is a -1. So because it's a -1 charge, and when you crisscross them, we can find out copper, so it's copper 2. Okay. The last example would be nitrogen triiodide. So nitrogen, N, and then triiodide, so 3 iodines. So I hope this review helped you prepare for your Unit 2 test in chemistry. That's on Tuesday, 9/29/2020 during your assigned class period.